So hello, in this video we are going to explain our project about a radar with ultrasonic waves. My classmates are Juan Pablo, Cesar Julian and me, Adriana. So the general objective is to program an ultrasonic sensor based on the emission and reception of sound waves, capable of detecting objects with precise distance and angles location. A specific object, the first one, is determine the fundamental equations describe the behavior of the radar, considering parameters such as range, resolution, frequency, and angles detection. The second one is described in detail. The principle of operation of an ultrasound sensor includes its ability to emit, receive, and process signal in the detection of objects. The third one is validate the accounting of the distance and angles value, proved by the software through experimental and comparative tests, real measures. Ultrasonic waves are sound waves transmitted and frequency about 2000 Hz. This project explains the operation of the ultrasonic sensor, which by means of ultrasonic waves emits signal that allowed us to determine the distance on which an object is located, using the time of flight and speed of sound, as well as the determinant of the angles of the incident and reflect wave. An ultrasonic uses mechanical ultrasound waves, generally between 20 kHz and 17 kHz, frequency about the range audible to the human ears. To measure the distance of the theft object, the type of wave is a longitudinal sound wave, in which the particle in the medium vibrate in the same direction as the wave propagation. The sensor generates an ultrasonic wave through a piezoelectric or similar traduce. This wave travels through the air or any gaseous or liquid medium through an object. The sensor detects the reflect wave by means of ultrasonic receivers, which measure in the time elapsed between the emission and reception of the waves. Ultrasonic waves are a propagation of vibrations which have a very small wavelength, which often the different phenomena associated with wave propagation. Ultrasonic wave propagation in an elastic material due to the success displacement of their particle. The elasticity of the material generates a restoring force that returns the particular point return the particular to their original position. But inertia causes them to continue moving beyond their equilibrium point, oscillating until their amplitude decreases. The different movement might by the particular as the wave path through they determine the type of ultrasonic waves.
The operation seems complex, but it is easier than it seems in to work with a servo motor which allows us to rotate between 0 and 108 degrees. An ultrasonic sensor is used on the servo. We use programming in Arduino for the movement of the servo and the measures of the sensor, with a program called processing with created the graphic interface which connects to the Arduino IDE from the which interprets the data in a data type interface. The ultrasonic sensor works through 4 pins: voltage, ground, echo, and trick. The echo pin receives the signal from the Arduino which stage is to send a sound, and the trick pin receives the signal when in the return for having collision with an object. It is sent to the Arduino and the distance is calculated with to speed and time, an effect like that of the echo. Here we have the equations that mathematically explain the operation of the ultrasensor. The first form allows us to calculate the distance at which the detected object is located. Can knowing the speed of sound in the medium, in this case with the low, the project where the medium is higher at the temperature of the approximately 20 degrees. However, the operation the ultrasonic sensor can be present in liquid and solid media. Multiplied by the measured time, which refers to the total time it takes for the ultrasonic wave to travel from the sensor emitter to the object and return to the receiver, and how we are interested only the distance of one wave. From the sensor to the object, we divided the total time by 2.
Calculation. Here we had an example of how the equation is applied to calculate the distance. Application. Civil engineering. Ultrasonic sensors are used to identify cracks, internal cracks, and delimitation in concrete, steel, or in composite materials. Industrial engineering. They are useful in industrial processes to detect and control processes without physical contact. For example, in packaging line, in ultrasonic sensor verify the position of bottles before filling them. Mechatronic engineering. To design robots, for example, a vacuum cleaner uses ultrasonic sensor to detect for tuner and clean without crashing. Conclusion. Determine the fundamental equation describing radar behavior, considering parameters such as range, resolution, frequency, and angular detection. Described in detail the principle of operation of ultrasonic sensor, including its ability to emit, receive, and process signals for object detection. Validate the acquired of the distance and angle value provided the software by means of experimental and comparative tests with real measurements. 2. The ultrasound sensor emits high frequency with bits process the reflected signals and calculates the distance, speed, and direction of objects offering precision and efficiency in the rotation. The acquired of the software was validated through experimental tests, demonstrating in a very precision of distance and angles, confirming its reliability.